Example 7. The Hubble Space Telescope was deployed on April 24, 1990 by the Space Shuttle Discovery. A model for the velocity of the shuttle during this mission from liftoff at t is equal to 0 until the solid rocket boosters were jettisoned at t is equal to 126 seconds is given by the following function. V of t is equal to 0.001302 t cubed minus 0.09029 t squared plus 23.61 t minus 3.083 in feet per second. We want to use this model and estimate the absolute maximum and minimum values of the acceleration of the shuttle between liftoff and the jettisoning of the boosters. So what we need to do is we need to find the derivative, of the velocity. That means we're looking for the acceleration function. So the acceleration function is going to equal the derivative of the velocity function. So the derivative is taking 3 and multiplying it by 0.001302, which gives us 0.003906 times t squared minus 2 times 0.09029 gives us 0.18058 t, and then plus the derivative of 23.61 t is 23.61, and the derivative of negative 3.083 is 0. So now what we want to do is we now want to find the derivative of the acceleration function. So what is the derivative of the acceleration function? Well, if we go further, 2 times 0.003906 gives us 0.007812, and that's t, and then that's going to be minus the derivative of 0.18058 t is minus 0.18058, and then we know the derivative of the constant 23.61 is 0. So now what we're going to do is we're going to set this acceleration function equal to 0. So we have 0.007812 t minus 0.18058, and we're going to set that equal to 0. So what that tells us is if we want to solve for t, then we know it's going to equal positive 0.18058 divided by 0.007812, and that gives us a value of 23.12. So now we want to look at 3 different time intervals. So the time intervals that we're given, the first one is we want to find out at t is equal to 0. And then we also found in step 3, we also want to find out what happens when t is equal to 23.12. And we also want to figure out what happens when t is equal to 126. And then what we're going to do is we're going to plug it into the velocity function, which is the acceleration function. So the acceleration function, a of t, in step 1, we're going to plug in 0. So from step 1, we're going to plug that in. And so that's going to equal 0.003906 times 0 squared minus 0.18058 times 0 plus 23.61. Well, that gives us 23.61. And so a of 0 is going to give us 23.61 feet per second squared. So now let's find out what happens when we find a of 23.12. So we're going to plug it into our acceleration function. We're going to square that, minus 0.18058 times 23.12 plus 23.61, and that's equal to 21.52 feet per second squared. And if we plug in A of 126, well, that is 0.003906 times 126 squared minus 0.18058 times 126 plus 23.61. Rounding to two decimal places is 62.87 feet per second squared. So let's take a look at all three of these points. We know that we have a point at 0, 23.61. We also have a point at 23.12, and that gives us a y value of 21.52. And then we have 126 and a value of 62.87. Okay, so let's take a look here. We can see here that this y value is smaller than the first y value at 0. So therefore, this represents the minimum. So this is the minimum value. And then, if we look at this y value here, this is 62.87, and that's going to represent the maximum value.